Started maybe?
Hello, everyone. Welcome to our latest workshop for the Sui KuCoin Lab Summer Hackathon. So my name is Henry, and I'm a part of the APAC DevRel team for Sui. So today's workshop we have Michael from MovEx, and the topic we're going to be talking about is going to be integration with DeepBook. So like Michael, maybe you can tell us a bit about yourself and then about what DeepBook is.
Yeah, sure. Thanks a lot, Henry, for the intro. So mine's Michael. I'm the founder of MovEx. So for this workshop, like we are going to do a deep dive in DeepBook. DeepBook is a fully on-chain central limit order book, built by the MovEx team, my team, together with the Sui Foundation. And yeah, without further ado, let's go into the presentation. So like I mentioned before, like DeepBook is Swiss native central limit order book, and it's built to bring kind of like deep liquidities for everyone who would like to participate in the DeFi ecosystem on Sui. And like in terms of the overall architecture, here's a short diagram where other DeFi protocols can plug into DeepBook through our user interface. And within DeepBook, there are a few different components: the matching engine, the smart routing, the open API, and we'll do a deep dive in each of these components one by one. And DeFi protocols on Sui chain can always have efficiently and effectively utilize the shared liquidities provided by DeepBook. Yeah, so actually, like before we dive deep into DeepBook, let's go through a little bit about the basics of a central limit order book, just to give you some context information. Um, so central limit order book, like in short for CLOB, is a is essentially the matching engine for a lot of used by a lot of the centralized exchanges, and not just centralized exchanges, but like also there are like decentralized exchanges using central limit order book as well. But here's a very typical user interface that you'll see for a central limit order book. This is screenshot taken from Kraken, one of the largest centralized exchanges in based in the US. On the right hand side, you can see a K line chart, which denotes the price movement of the particular token pair. There's a for a particular token pair, there's a base asset and a code asset. In this case, base asset is Ethereum and code asset is USDT. This K line chart will show you the essentially the price at each particular timestamp, the trading volumes, and some of the other metrics. In the middle column, what you'll see is the oh sorry. In the middle column, what you'll see is is what is called the L2 depth of the order book. So essentially, what that means is that you can see these prices and quantities. They represent the total number of amount of orders at that particular price level. For example, in our particular case, the tick size, since we are trading, here actually we are trading BTC against USDT, and the tick size of BTC is 0.1, which is the minimum difference between two adjacent price level. And on the right hand side, you can see the total amount of BTCs being placed into the order book. So actually, you can see the upper half is shown as red, lower half is shown as green. Upper half are the asks from the book, and the lower half are the bids from the book. And you can always see there's a price difference between the highest bid and the lowest ask, and that is called the spread of the order book. and the spot price of the order book is essentially just the average between the highest bid and the lowest ask. On the left hand side, like you can see the like you can use the left hand side to interact with a central limit order book. Normally, the way you interact with the club is by like with two approaches. First one is to place like limit orders, and second one is to place market orders. So like in this screenshot, I'm showing how you can place a limit order. When you place a limit order, you specify the limit price. Limit price is the price like you enter, and if you are placing a limit order, your order is not necessarily guaranteed to be filled instantaneously, but once it is filled, it's guaranteed to be at a like price no worse than the limit price. And you can also specify the quantity and also the expiration time for your for your order. When you submit a limit order, normally it will be injected into the club as a maker order. What that means is that you are actually in maker orders are essentially injecting liquidities to the order book, compared to taker orders, where we are going to cover in the next slides. So here what we are showing is the second way of interacting with the central limit order book, which is essentially placing a market order. Market order are all treated as a taker order. The difference between like market order and limit order is that market orders will be filled in the order book instantaneously, and you don't have to wait for your order to be filled in the case of you when you place a limit order. But the drawback of placing a market order is that there's no guarantee of there's no guarantee of the price where the order will be filled. Yeah, so just keep that in mind. And let's do a quick summary of what we just said, how in terms of how to interact with the central limit order book by placing limit orders and market orders. So first, limit orders usually injects liquidity to the market, like they inject into the L2 debt, this graph here. And the limit order is filled as a price no worse than the limit price set by the user, in this box. And but limit orders are not necessarily filled instantaneously. Normally, limit order have to stay on the order book for a while and wait for other market orders or taker orders to be matched against these limit orders. And limit orders, users who are submitting limit orders, will also receive a rebates. What that means is that these rebates are paid partially paid by the the takers. Takers will pay commissions, and a certain percentage of the taker commission will go into the makers as rebates. So what that means, just like in plain English, what that means is that if you are placing a limit order and your limit order is treated is filled as a maker order, you can actually receive some additional amount of quote tokens. Second one is market order. Market order, like I mentioned, normally consumes liquidities from the L2 debt, consume these red bars or green bars. They are filled instantaneously at a best price available. And users who place market orders will have to pay for a trading commission when these orders are filled. So just a quick diagram to show the overall club workflow. When users are placing limit orders, like mentioned, the liquidities are being injected into the corresponding price levels. When users are placing market orders, their market orders are normally consume liquidities from these price levels. Users can also cancel their limit orders. If they do that, there will be a corresponding amount of tokens being deducted from the overall order book. Okay, so here's this is essentially the basic workflow of a central limit order book. Now let's dive deep into the overall architecture design of DeepBook. So essentially, so this is the high level architecture graph of DeepBook. Essentially, DeepBook is structured as in the following way. For each currency pair, for each base quote asset pair, we actually will create a shared object representing the pool between those token pairs. The benefit of doing that is that people can actually highly parallelize transactions across these different pools without any latency across these different pools. For each specific token pair pool. So for example, in the case of Sui USDT pool, here Sui is the base token and USDT is the quote token. So there are a few important fields. First is that the pool will keep track of all the open orders, bid orders, ask orders within the pool, and also there's also a structure called a custodian, which keeps track of the the user balances, when which keeps track of the user balances when they deposit and withdraw funds into the pool or from the pool. We have two separate custodians, one for the base asset Sui, the other one is the quote asset USDT. And also we have we also have a trading fee fields which aggregates the trading fee for that particular pool, and all the trading fees are denominated in quote asset. And we also have a field called user open orders map, essentially that maps from the user ID to all the open orders that are not yet filled when in the club. And here's also the diagram showing the overall architecture of the custodian account. So essentially just a table which maps from the user ID to two balances. One is the locked balance, the other one is the available balance. Locked, when users are deposit funds into the pool, they become available. But if users are placing a limit orders, some of the balances from the available available balance field will become locked. And once users cancel that orders, or the users or the orders are getting filled, these locked balances will become available again. Yeah. So next one, let's look into the workflow, specific architectural diagram of the workflow on how we are handling each of the transactions that I mentioned in the previous slides. So in the first one, place limit orders, first users need to deposit base or token into the custodian account. If users already have tokens available in the custodian account, that is fine. They can reutilize these balances within the custodian account. And when users are placing limit orders, first some of the available balances will become locked balances. Say for example, if you are placing a limit ask order for Sui, some of these available Sui tokens will become locked. And if you are placing a limit orders where if you are placing a limit orders where you where you tries to bid place a bid orders on Sui, some of the available balances for USDT will become locked balances. And then the orders will be injected into the corresponding bid orders and ask orders. Later on, we'll discuss how what kind of structure we are using to keep track of the bid orders and the ask orders. And at the end of the transaction, the users will get a unique U64 order ID from the transaction, which can be used later on to track by the users to track the orders, to cancel the orders, or to check the status of the orders. Okay. Next one is like how users are. Next one is the workflow of like users canceling like limit orders. Like so essentially this is the reverse of the like placing a limit order. Like first the like orders will be removed from the bid and ask orders like structures, and then like the corresponding locked balances will become available again by users to withdraw. And like the last one is optional. If the users no longer want to place orders into the order book, they can withdraw these balances from the custodian account. Yeah. So third one is like how users can place market orders. Place market orders is like is a little bit like more straightforward than placing limit orders. Market orders will first like go through the bid orders and the ask orders according to the either the increasing order of the price levels, or the decreasing levels in decreasing order or of the price levels, depending on whether the order is like like bid order or ask order. And this like the taker order is then matched against the order book, against the existing limit orders. And for each like limit order, the corresponding like custodian balances will be updated once the order is being filled. And like finally the differences between the taker commission like paid by the paid as a additional like amount denominated in the quote asset, and and maker rebates, sorry, and the differences between the taker commission and maker rebates like actually will goes into the trading fee field. Yeah. Yeah. So another thing that I would like to emphasize is that like the composability of the book. So this is a like a very like interesting part. So like you might be thinking like if we think about it, like when users are placing like limit orders or canceling limit orders, we need some like structure to keep track of the open orders on the order book. So how do we do that? We like you might be thinking maybe we can just like track the orders using the sender's address, like to keep track of the open orders, and also keep track of the user balances. That is actually not the case. Like using user addresses to keep track of the the user balances and the open orders actually could cause some like potential problems. Because like maybe there could be some other DeFi protocol who would like to place an order as well, and and then actually the DeFi protocol itself need to keep track of the actually the custodian account and the limit orders like structure should keep track of the balances and the limit orders placed by that DeFi protocol rather than by the user who is sending the transaction. So to solve that problem, the orders and the balances are tracked using the UID of the structure called account cap rather than the user address, which who is like sending the transactions. That like greatly improve the overall composability with other DeFi protocols. In order to use these features, users or other DeFi protocols can simply create an account by like generating an account cap object from the by calling the corresponding function in the club, and then we'll use the the UID to keep track of the to keep track of the account balances and also the limit orders on the order book. And when users are placing a order or canceling an order, they need to pass in the account cap, corresponding account cap, so we can identify the corresponding balances and limit orders. Yeah. Finally, like we briefly mentioned that like there's a structure we used to track open orders, these bid orders and ask orders. So essentially, like open orders are are tracked like using a creepy trees. A creepy tree is a binary prefix tree with like path compressions. If you are familiar with like kind of college like data structures, you might have heard of like such like techniques before. And like in terms of why we want to like use creepy trees, the reason is that like insertion, search, and removal of all like from creepy tree all have like amortized complexity of O log n, where n is like the total number of like entries within the tree, which is the most efficient like data structure that is currently that can be thought of. And also iterating over the leaves of the tree is like very efficient. Remember that when we are matching like make taker orders against like maker orders, we actually need to iterate through all the entries within the club. So yeah, that's the reason why we need like to use creepy tree for like for the open orders. Yeah, so that's like the end of my presentation. Hopefully like you have learned something about like DeepBook, and hopefully it could be helpful to everyone who is like thinking about like building DeFi protocols on top of like on top of the switching. Actually, like we have like released a a beta testing program for DeepBook on Sui, and we have released like our front end, released the front end on our website. If you go to app.movex.exchange, you can actually play around with DeepBook on testnet. And later on, like once like DeepBook is ready for mainnet, we'll also make an announcement, public announcement together with Sui, and invite everyone to come into like DeepBook and play around like with it. Yeah. Thanks. Like, let's see if we have any questions for the workshop.
All right, great. Thank you very much for that workshop, Michael. Um, so this is really cool. So for like DeepBook, is it also about to launch like relatively soon on like mainnet as well, or like is this
Yeah.
like in the planning or yeah?
Yeah, so we are already like collaborating with members from Mason Labs and Sui Foundation to like launch DeepBook on mainnet in in the short term. Yeah.
Great. So now is already live on testnet, and it will
Yeah.
be live on like mainnet in like pretty soon. So
Yeah.
this is a great time to integrate your app with like with this for any teams that are building kind of like DeFi or like payments type apps or like exchange type apps. Yeah. Um, okay, let's see if we have any questions. I currently don't see any questions in the chat. But I think once we upload it, people can post questions in the comments. Yeah.
Yep. Sure.
All right. I think that this will be it for our workshop then. All right, Michael, thank you for coming on. Yeah.
Okay. Cool. Yep. Thanks. Thanks a lot.
All right, great. And thank you everyone else for like joining as well. All right,
Cool.
bye.
Thanks. Bye.